Okay, this next example we'll have we're going to work with this. Now, we're trying to choose U and DV. Usually we let our DV be the more complicated part, but if you recall back when we listed the U's to choose, we always choose when there's a logarithmic function that to be the U. Okay, so whether you use that format or you just kind of remember this, because I like to choose DV first personally. But in this case, when they have a natural log, a logarithmic function involved, you're going to let that be U. Okay, so if we let this be U, then dv is just going to be what? Good. Or a 1 just dx. Or you can just have a 1 there. Alright, so let's calculate du. What's the derivative of the natural log of x? Good, 1 over x dx. Now what about if we take the antiderivative of this, which is just a known 1, what would that be? X. Good, plus a constant. Now let's come over here, interval of u dv equals u times v minus interval of v du. So let's do our u, natural log of x, v is x, minus v is x again, and then du is 1 over x dx. Just going to simplify this, x natural log of x. What happens here algebraically? We just get 1 dx, so let's just simplify that and now evaluate it. So what do we get for this term? Minus x, and then we just have plus a constant. Now, we could factor out an x there, but not necessarily. Not necessary. Okay? But be familiar with factoring stuff out for equivalent answers. So let's do, I want you to practice the table form of this. Remember this, your u is going to be the natural log of x. This is going to be a little bit different. So we'll have u and then dv. We said u was the natural log of x, and dv is 1 dx. So anyway, what's the derivative of the natural log of x? 1 over x. Okay, and then here we would just get x. Now typically we would do this until we just get to a 0. Well, that's not going to happen, right? It would just keep going and going and going. So just like we thought, well, these problems with natural logs are a little bit different. When we do their table, they're a little bit different. So we're still going to have that similar concept when we're going to do this times this, which would give us x times the natural log of x, and of course this is a positive sign. The next one we would go down, but of course we said this isn't going to happen in this case, so we go across. But when we're going across, we have to actually calculate the antiderivative of the next term. So we would just say the integral of this term times this term. Because going diagonally, it lets us automatically calculate that, but we don't have that option. So here's what we're going to work with when this is the case. So if we go straight across, you have to include this step. All right, so then now we're back at, algebraically, that simplifies to just 1 dx. And once again, we just get x natural log of x minus x plus a constant, which is what we had before. But that's the most basic natural logarithmic one that you will see. We'll see some more in just a minute. Okay, let's see another one of these. So first of all, we said we like the dv to be most complicated, but when we have a logarithmic function, we're going to let that be our u. So if this natural log of x is our u, what's our dv going to be? X dx. Good. Du 1 over x dx. And what about when we take the integral of each side? That's just going to be x squared divided by 2, or 1/2 x squared, plus a constant. Alright, so write your formula and set up the first step. Okay, we have our u times our v minus the integral of v times du. I'm going to move x squared divided by 2 to the front. We can do that at any time. Now let's simplify over here first. A couple things going on. I can pull this 1/2 out front if I'd like. And then what about x squared over x? Just simplifies to x dx. Good. So algebraically simplify that. We would just carry this term down. And this is going to be my 1/2 is there. So what happened? What's the antiderivative of x dx? X squared divided by 2, and then we have plus a constant at this point. Let's go ahead and simplify this one more step. Natural log of x minus, what's that, 1/4 x squared plus a constant. Alright, and the next thing I want you to do is test this with the table. So u dv. U, we said natural log of x, and dv, you told me x. What's the derivative of u? 1 over x. Now, this next one's not going to end up to be 0, so at this point we're going to stop here. So let's just finish the table. What would this one be? Take the integrate x, and you're going to get x squared divided by 2, and we're going to stop. Now, we said for this one it's going to be this term times this term, which is the x squared divided by 2 natural log of x. And then we would have to say, since we're going, this is plus, and since we're going straight across, we have to have the integral of that, this term times this term, and that's simplified. So it's basically puts us right back at this step, you know, and then it'll continue through. So that's the only thing I want to remind you of, especially when you use a table form of a logarithmic function, that here you have to still show the integrate step. Okay, let's just practice using the table form on this one. So u dv. So tell me what you think here. What do you think we're going to let be our u? The natural log of it. If it's got a logarithmic function in it, we want to let that be our u. Typically, we let the most difficult thing be dv, but when we're having a natural log or a logarithmic function in there, we automatically choose that to be u. So then what's this going to be? Instead of 1 over x to the 5th, how could we write that? Good, x to the negative 5th. These negative exponents will help in the calculation. What's the derivative of the natural log of x? 1 over x. And then what is the antiderivative of this? First of all, it's going to be x to the negative 4th, and then I have, negative 1/4, x to the negative 4th. Alright, so this is going to be plus, multiply them together. So I'm going to have natural log of x, negative 1/4, x to the negative 4. So that represents our u times our v. Because this is natural log and we're going straight across, I still have to have the integral of that times negative 1/4 x to the negative 4th dx. Okay. If I pull my negative 1/4 out front, then that's just going to be natural log of x. And then what about that x to the negative 4? I can just make it a positive exponent by pulling it to the denominator. Now, this negative 1/4, if I pull it out front, what's a negative times a negative? Positive 1/4. Now let's simplify this as much as possible. If this is x to the negative 4 and this is an x in the denominator, what does it simplify to be? X to the negative 5, right? Because I can either pull this up as a negative 1, right, so that you can see it in that sense. So simplified form, we'll have that. This term I just Bring down negative natural log of x over 4x to the fourth. Now what am I going to get when I evaluate this? What would give me plus 1? I'm just going to have, I will get negative 1/4, and then I'll have x to the negative 4, or I can go ahead and bring it down there. Last step, let's just simplify everything. So just this term was already simplified. X to the fourth minus, let's see, so that's going to be negative 1 over 16 x to the fourth plus constant.